Hello friends, welcome to Risingpearl.com. We are talking about series 2 and learning a lot about triangles. Today is webisode number 11 and we are going to continue to learn how to solve questions and problems that relate to basic proportionality theorem, and the last two theorems we have looked at. This is a part 4. It was webisode number 8 since we started, where we started looking at how to solve problems based on these three theorems, basic proportionality. What are the other two theorems? Well, the two theorems are basically one the converse of the other, or the opposite of the other. So the theorem basically went something like, if you have a line drawn inside a triangle such that if that line is parallel to one side of the triangle, then that line divides other two sides of the triangle in the same ratio. And the other theorem is really just the opposite of that. So we have looked at these in our earlier webisodes, and I'm going to provide all those links right below here for your easy reference. Now, as we saw earlier, friends, whenever we see questions that relate to these theorems or concepts, we are going to focus on which ratios do we need to look at carefully. We will then also be looking at which one triangle or more than one triangles, maybe which triangles are involved. And we will keep an eye out for any line that is parallel to a side of a triangle. That is, as we solve these questions, and this is what we have been seeing for the last few webisodes, webisode 8, 9 and 10, that our goal is, because all of these theorems they relate to a triangle, so we want to pay attention to a triangle or triangles. We want to be on a lookout for a line parallel to one side of the triangle and then understand which ratios may be involved. So point number 1, 2 and 3, generally we will be always on a lookout for these three things in questions that come up for these topics. So having said that, let's take a look at real question. So here in the figure below, PQRS are points on AO, BO, CO respectively, such that PQ is parallel to AB and PR is parallel to AC. So we have to prove that QR is parallel to BC. So first things first, friends, I mean, when you take a look at this figure, you'll be like, wow, this looks like a super complicated diagram, and I will agree with you. But if you just take a simplistic view, you will see that I have a triangle ABC, right? There is some point O in the middle, and AO, BO and CO are joined. Then on AO there is a point P, on OB there is a point Q, and on OC there is a point R, such that these lines are parallel. That is, PQ is parallel to AB and PR is parallel to AC. And we have to prove that QR is parallel to BC. So friends, how are we going to start this question? So we are going to first focus on this triangle AOB. Why? Because I have a pair of parallel lines. Right, so if I look at triangle AOB, I don't know at this point where we are going with this, but what I do know is I have a triangle AOB where PQ is parallel to AB. So what does it tell us? So it tells us that in triangle AOB, in triangle AOB, I can say that OP by PA, I can say that OP by PA should be equal to OQ by BQ. Why? Because simply PQ, it is given PQ is parallel to AB. So if I have PQ parallel to AB, PQ parallel to AB, then from the theorem it follows that these ratios should be equal, right? Because then PQ divides OA and OB in same ratio. So this must be true. I call this equation 1. Now, similarly, we have been given PR is parallel to AC. So as you can absolutely imagine, we are going to shift our focus now on this triangle highlighted in blue. That is the triangle, let's write it here, triangle AOC. AOC. In this triangle what we have is PR parallel to AC. So that means OP by PA, OP by PA, that is this ratio OP by PA must be equal to OR by RC. OR by RC. Why? Again, very similar reason. PR is parallel to AC. This is given to us. So from theorem we can say that these two ratios are same. Let's call this condition number 2. So if you look at condition 1, condition 2, you will notice that this ratio is common. That is, in now let's do one thing. Let's get back to our original triangle. So what we have from equation 1, equation 2 is that OP and PA, this ratio is common in both the conditions. So we can write this as OP by PA equal to OQ by BQ, OQ by BQ. This is condition 1, and this ratio is same as OR by RC. So from here we can say that these two ratios are equal, that is OQ by BQ is equal to OR by RC. So what we have, friends, is OQ by BQ is equal to OR by RC. So what does it mean? It means that now if you look at this triangle, that is now if you look at triangle BOC, in triangle BOC I have the line QR drawn in such a way that this ratio is true. So what does it mean? So in triangle BOC highlighted in blue, QR is a line drawn in such a way that OQ by BQ is equal to OR by RC. So from the third theorem it follows that absolutely this line must be parallel to this line. So it follows from the theorem that QR must be parallel to BC. And friends, this is exactly what we had to prove in the question. So as you can see, friends, even though initially it looked very complicated, but by sticking to our steps, systematically we have proved the question, we have solved the question. Let's take a look at one more question before we wrap up this presentation, this webisode. PQRS is a trapezium with PQ parallel to RS. Its diagonals intersect at O. Prove that this ratio is equal to this ratio. So friends, here I have drawn a simple trapezium, and we know what is a trapezium, right? Trapezium is nothing but a quadrilateral where one pair of opposite sides are parallel. So for convenience, I have drawn PQ parallel to RS like this. And it is given that PQ is parallel to RS. So we have drawn PQ parallel to RS. These are parallel sides. And PS and QR are the non-parallel sides. Then its diagonals intersect at O. That means we need to join the diagonals S and Q and P and R, and they intersect at O. We have to prove, let's see now, look at what do we have to prove. PO by QO. PO by QO is equal to RO by SO. So this ratio that we have to prove, it is all about the diagonals. So how do we solve this question? Well, first what we are going to do is, from the point O, we will draw a line TO such that TO is parallel to PQ. And why am I doing that? You will see this in a moment. So what we did was, from point O, we drew a line parallel to PQ intersecting PS at point T. That is, TO is parallel to PQ. That is the construction we did. But because PQ is parallel, so this is our construction. But because PQ is parallel to RS, which is given, this is given, so what we have is TO is also parallel to RS. So all these are parallel lines. So this implies that TO is also parallel to RS. Right? Now let's continue with our proof. So first we are going to focus on triangle PSR. Why? Let's take a look. In triangle PSR, what do we have? In this triangle, we have TO parallel to RS. It means that PT by TS must be equal to PO by RO. Right? Because TO is parallel to RS, right, in this triangle highlighted by blue. So PT by TS must be equal to PO by OR. So if you notice, friends, here I have got the ratio of one of the diagonals. So PO by RO, PO, so this is my ratio of one of the diagonals, right? And I am expressing that in terms of PT by TS. Let's call this as this equation as condition 1. Now we are going to focus our attention in this triangle SPQ. So in SPQ, what we have is TO parallel to PQ by construction. So in triangle SPQ, ST by TP, ST by TP is equal to SO by OQ. So friends, here you take a look at this. So by selecting this triangle, what I have done is, now I have got the ratio of the second diagonal, which is SO by OQ. Right? This is my second diagonal, and I am again expressing this in terms of ratio of this side PT, which is common. So let me call this condition 2. So from condition 1 and condition 2, equation 1, equation 2, what we can write is PT by TS, right? So let us write it here. PT by TS is equal to PO by RO, which is equal to, so PT by TS, so here we need to take a reciprocal of this, right? Because we are writing PT by TS, so this will go in the numerator, this will come denominator. So it will be equal to OQ, so this also will be, we have to take the reciprocal of this. So it will be OQ by SO. So that means that this ratios should be equal. So from here we can write PO by RO is equal to OQ by SO. Isn't this what we have to prove? We have to prove PO by OQ. Alright, so we have to do a little bit of rearranging. So we have to have PO on the numerator, PO, but denominator is OQ or QO. So we want to bring this here. So let's see what happens. So this basically implies PO by OQ equal to, so if you bring this down, you take RO over here, it will be RO divided by SO. PQ by QO, PQ by QO is equal to RO by SO. This is exactly what we have to prove, and we have proved it. So sometimes, friends, as you notice that you may need to, rearrange the ratios a little bit to exactly match what is given in the question. But again, sticking to our steps, this is how we solve these questions. So friends, I hope that you have been following us along, and at risingpearl.com here, we are really focusing in the last 4 webisodes, we really focused on how to solve questions that come up based on these theorems.